Okay, so right here, what you're looking at is the Fibonacci sequence running right here. Okay. This is here this is what they call the Lucas sequence out there. This is a third sequence. It's barely known out there at all, but it is out there, but doesn't even have a name. I have a name for it, but I'm not going to get into all that anymore. I've already made some videos on this stuff before, and quite a miracle that nobody really seems to get it or understand or care. It's quite a miracle. Seems people want entertainment, not actual information. To me, the world's lost its mind in more ways than anybody can even fucking count. So what we have here is these three sequences right here. And they produce these 3, 6, 9 sets right here. All three of them do exactly the same thing. So back up there a little bit. We'll start back over here on this, what they call the Fibonacci sequence. I don't call them as myself, so I'm going to work with everybody on these YouTube videos since people like entertainment. So you see right here and the 21 right here, 2 plus 1 equals 3. So there's a lot of digital root works with what I have. So that's what you have right here is the digital root. 2 plus 1 equals 3 right here. The 987 right here is going to equal 6. The 46368 is going to equal 9. And in the purple here, you can see where there's a purple, the 144 right there. That's going to equal a 9. The 6765 is going to equal a 6. Okay. 317811 is going to be a 3. So it's going to produce these two sets of 3, 6, 9. It does that all the way down here to do it forever as you move this, increase the length of the numbers on here. See the 963, 963, 963. Of course, these are in the reverse, 369. And this one right here, we'll go over to this so-called Lucas one. It does the exact same thing. It's 369 and 963 on both sides of these. And of course, there's the third one. Okay. And what I just showed you right there, as near as I know, nobody even knows any such thing exists like that. Maybe, but it's not out there. Probably because people want entertainment. They don't actually care about this factual, mathematical proof of what's happening right here. So we're going to look over here again at this right here. These two are swapped around. You can see the 112,358 right here. These are now all in digital root. All these right here, it's exactly the same, but they've been reduced down to its digital root right here. You see the 112,358 and 13. 1 plus 3 is going to be the 4. Okay, and it goes all the way down. And over here is the so this is the Fibonacci. This over here is the Lucas. These are flipped around because you can see again the 112,358 is over here, but on this side of this paper over here it's this way. That just ended up that way because when I was first started drawing these papers, which was years ago, I think it was like probably 3 years ago that I produced these papers. And I didn't even know what was going to unfold in producing these. I did not know. It's turned into. I have a lot of different papers on this, but I'm showing you these two papers right here for a particular reason. We'll get to in just a minute. So you can see there's the 257 right here. 257 right there. And when you put these in this order right here, there's an interesting thing right here. The 257 has to be in the center in order for this to work at all. You swap these around in any way. I mean, you take this one and flip it over there, and this one back over there, the Lucas and the Fibonacci. But this one right here, the 257, has to stay in the center in order to produce these numbers right here. Okay. So again, these are all digital roots of these numbers that are right here. I just showed you. This right here. And so here you go again. These are what's happening here. What's happening is the 1 plus 2 equals 3. 1 plus the 5 equals 6. And 2 and the 7 is going to make a 9. And these over here, you can see right here where this is going to be the 2 and the 3 is going to make a 5. 2 and 4 makes a 6 over here. 4 and the 5 make a 9. So there's two sets of numbers right here that this is producing. So the outer set right here is going to produce these 3, 6, 9s again. And here they go right here. See this 3, 6, 9 on this one. Again, adding the center one to the outer one, you're going to get this right here. And it even produces a whole nother set of 3, 6, 9 outside here, working off of this line right here. So you've got two sets of 3, 6, 9 running down here. It's been a while since I looked at this paper because there's actually a third set of 3, 6, 9 right here. You see on this inner set of numbers, the inner line in here, you got this 6 right here. There's the 6 over in the red right here. You move down here again, you have, there's a nine over here, 9, 6, there's a 6 there, 3. Yeah, there's 4 sets on here. Like I said, it's been a while since I produced these papers. I haven't even brought these out for a while. So over on this side, it's doing the same thing again. Exactly the same over on this side. It's doing it right over here. And there's more over here. That is the numbers from this, from where we're at. There's the 718. That's the 718. That's going to make a 7. And then there's this 85. What's that? 887. That's over here. That makes a 7, a 5, which is going to make a 3. These right here are all going to be produced off of this line here. This then produces this 3 and 6, 3, 6, 3, 6 down here, which then goes back to 9 right here. And again, it does the same thing over on this side. Nobody has any drawings like this out there. Again, I've made some videos on this before, and shockingly got nearly no views because people like entertainment. I'm not an entertainer. So here's where this comes to you right here on this one right here. I produced this paper, this drawing about, I don't know, few months ago, put it onto YouTube, made a 1-minute little short on it, and it got a few views, no comments. That's another thing, no comments on any of these papers. Absolutely shocking. Absolutely shocking. This right here is quite stunning, what's happening in here. Here, let's start with this Fibonacci one. Here's the 1 if you go back here, here's the 1, 1, 2, 3, 5, 8, right? 4, 3. Right here. 1, 1, 2, 3, 5, 8, 4, 3. Okay, goes all the way down. That's what this is going to do. It's going to go all the way around. And it's going to go around here 24 digits. And then it will start all over again in the same exact order that it started in. So, moving to the center right here, there's the 257, 334, 257, and 257, yeah, 314. So kind of like, what the heck? 257, 314. 257, 314, okay. That goes all the way around, also 24 digits before it'll start over again. There's in the green is the 347, that's the Fibonacci one. Okay, 347, 292. Yeah, 347, 292, okay, continues all the way down, all the way around on this paper right here. So, there's a few interesting things to note on here. You can see right here where it has a 1, 2, 3 order right here. And right here is a 1, 2, and 3 straight across in this line right there. You got the same thing happening right here. Of course, it's a 1, 1, 2, 3 on this, but it's, you know, it evidently where it really wants to start is right here in this 1, 2, 3. The 1, 2, 3 and the 1, 2, 3 across there. It's got 1, 2, 3, 1, 2, 3, 1, 2, 3. So that's just a minor little thing to note in there, because here's the bigger thing to understand in here or look at. And that is that you can see the order that's in here. The entire wheel right here is all in a 369 order in here. You can see right here these 369s that are boxed in right here, circled right here. There's 2 sets of them. There's an outer set and the inner set. Of course, that makes 3 of them. The creator, which people are going to understand very soon in a series of videos that I'm going to be producing over the next week or so. The creator works with the number 3 and 9 hugely, and 3, 6, and 9, and also the number 1, and an order of 1, 2, 3, 3, 6, 9. You see that right here on this paper. You have 3 sets, or 3 3, 6, 9s on the outer and 3 on the inner, making 3, 6, and 9s. And how that works is you take the center digit and add it to the outer one. On this case, it's going to make a 9. Again, you take the outer one and add it to the inner one, it's going to make a 9. Take the center and add it to the outer, it's going to become 6. Take the center, add it to the 9, that's going to make 12, which 1 plus 2 is going to come back to 3. Okay, that's what all these are doing right here. Taking the center one and then adding it to either the outer one or the inner one. And you're going to come up with this digit for the right here that are boxed in right here in these. Okay. Check any one of these. Just flip this thing around. Right here, you have 8 plus 7 equals 15. 1 plus 5 is 6. 8 plus 4 equals 12. 1 plus 2 is 3. Any one of these. 7 plus 8, again, equals 15. Going to give you 6. 2 plus 7 is going to give you 9. 2 plus 7 is going to give you 9. 6 plus 9 is going to give you 15, but 1 plus 5 is 6. Same thing here. 6 plus 6 is going to be 12. 1 plus 2 is 3. That's what this whole thing is doing all the way around here. Okay? These 9s right here, that's what's going to be the added, this is going to be the, when you add this boxed in 6 right here to this boxed in 3 right here, or 6 plus 3 is going to be 9. Now it's in reverse order right here. 3 plus 6 is going to be 9. And 9 plus 9 is 18, which comes back to 9 again. 1 plus 8 is 9. It's going to do this all the way around here. 3 plus 6, 9. Reversed. 3 plus 6, 9. Well, that one's not reversed. 3 plus 6, 3 plus 6. 6 plus 3, 9. 9 and 9, 9. It's an absolutely beautiful paper. This one. Again, I produced these probably like 3 years ago. I have loads of them. These are not the only ones. I'm done.